be talking about solving polynomial equations that are already in factored form, okay? So they've already been factored out. So remember, when we multiply something, that means that we're like putting something together, right? Factored kind of means that you're like taking it apart, all right? So the zero product property is really important, especially when you move into Algebra 2. So if the product of two real numbers is 0, so in other words, let's say I take 2x times 3x, and I set that equal to 0. So the product of two real numbers, so this is one real number, and this is one real number. Remember, our product means that we're multiplying. Then at least one of the numbers is 0. Okay? Well, that kind of makes sense because let's say that this is 0. 0 times 3x is 0. And that makes this a true statement, right? Or this one has to be 0. 0 times 2x would be 0. All right, this is important because if I'm trying to figure out what x is, then I could take that factor and set it equal to 0. So if you are looking at number 1 where it says solve each equation, you have a factor of 2x, and you also have a factor of x minus 4. And it's telling you that when you multiply these two together, it equals 0. Well, for that to be true, that means that either this factor has to be 0 or this factor has to be 0. So you're going to come up with two numbers that make this equal 0. So what you're going to do is you're going to take the one factor and you're going to set it equal to 0 because you're saying to yourself, what number can I plug in for x that would give me a 0 for this factor? And then you're going to do the same thing with the x minus 4. And in your mind, you're thinking, what number, if I plugged it in for x right here, would give me a 0? So all I'm going to do is solve for x. So I'm going to divide by 2. That gives me x is equal to 0. That means if I plug 0 in right here, 2 times 0 gives me 0. And one of my factors is 0, so this whole thing is equal to 0. Same thing here. I'm going to add 4. So x equals 4. That means that for this factor, if I plug in 4, 4 minus 4 is 0. That factor is 0, which means this whole thing is equal to 0. So on number 2, we have a factor of x minus 3, and we have a factor of x minus 9. So I'm going to take each of those factors and set them equal to 0. So over here, I'm going to solve for x. I will add 3. So I know that if I plug 3 in here, 3 minus 3 is 0 times the x minus 9 would still be 0, right? It makes this equation true. Same thing here. I'm going to add the 9. So when I plug 9 in, 9 minus 9 is 0, and that makes this whole equation equal to 0. All right, again, we have two factors here. We have 2x plus 7, and we have 2x minus 7. So I'm going to set both of those equal to 0. So if I were to solve for x, I would have to subtract my 7. That leaves me with 2x is equal to negative 7. And then I would go ahead and get rid of the 2, so I would divide by 2. And we all know I don't want decimals, so you're just going to leave that as negative 7 halves. So if I plugged in negative 7 halves up here, that would give me a 0 right here. All right, same thing here, except instead of subtracting 7, I will be adding 7. So I have 2x is equal to 7 divided by 2. So x is 7/2. Now remember, when we take a number or a binomial or whatever and we square it, that just means that we have that binomial times itself. So I'm going to write that as x minus 1 times x minus 1. Now I have two factors here, but they're both the same, right? So I don't need to actually set both of them equal to 0 because I'm going to get the same thing no matter what. So I'm going to go ahead and add 1. So x is equal to 1. So when you look at number 5, you have one factor, you have a second factor, and you have a third factor, all being multiplied together. So anytime one of them is equal to 0, then that means the entire equation equals 0. So I'm going to take all three and set them equal to 0. So x plus 1 equals 0, x minus 3 equals 0, and x minus 2 equals 0. And then I solve for the x. So I subtract 1, so I get x equals negative 1. I add 3, so x equals 3. And I add 2, so x equals 2. Actually, I have three answers on that one. There are three numbers that would make this equal 0. All right, same thing over here. I have three factors, d minus 2, d plus 6, and d plus 8. So set all three equal to 0. And then you're just going to go through and solve for d. So I add 2, so d equals 2. I subtract 6, so d equals negative 6. And I subtract 8, so d equals negative 8. So this equation has three solutions. If I plug any of those three numbers in, I end up getting 0. All right, so let's talk about greatest common factor. So a greatest common factor is the biggest number that will go into each term that you have. All right? So for the most part, if I look at 4 and 24, I should know that the biggest number that goes into 4 and 24 evenly is 4, okay? But I want to point something out because a lot of times people are like, 24, 16. Okay, the biggest number that can go into 4 is 4. So your greatest common factor is not going to be bigger than your smallest number, okay? So the biggest common factor you could have is 4. Like on number 8, the biggest common factor I could have is 8. So you're not going to give me a factor that's like 6, right? 4 doesn't divide by 6. So the best way, if you're not good at coming up with a common factor, is to actually do factor trees. So I'm going to do one at every single one. Now, do I really need a factor tree to know that the biggest number that goes into 4 and 24 is 4? No. But sometimes we struggle with that. So we're going to do some factor trees. So I've got 4 is 2 times 2. All right. And 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. So what we're going to do is we're going to write these out. So 4 is 2 times 2. And then you have 4x's being multiplied here, right? When I take something to a power, that means I'm multiplying that times itself that many times. So I have 1, 2, 3, 4. So that is the prime factorization of 4x to the fourth. Then you do the same thing with 24. So you have 2 times 2 times 2 times 3. So all of my prime numbers. And then I have 3 x's. X times x times x. Now you compare. We have a 2 in common. So I'm going to write that 2 down here. And then we have another 2. So I'm going to multiply that down here. But now I don't have any other prime factors in common, right? So I'm done with the numbers. And then how many x's do I have? I've got one set of x's, another set of x's, and another set of x's. That's what I have in common, right? Then you just multiply it. 2 times 2 is 4. X times x times x, that's x to the third. That's my greatest common factor. All right, that's what I have in common, right? So I know I didn't give very much space on here, so we'll just have to venture out to the side. All right, now I do want to point this out. Since you're matching x's, the smallest number of x's you have is your common x value. So I have 4 here and 3 here. Then I know that I'm going to end up taking out x to the third. All right, so you're going to put the 4x to the third on the outside of a parenthesis. And what you're going to do is you're going to take, and you're going to take this term, and you're going to divide it by the common factor. So I have 4x to the fourth, and I'm going to divide that by 4x to the third. What is 4 divided by 4? 1. Okay? Now, do I usually write the 1? No, I'm going to write it for now, and then I'm going to erase it. And then what is x to the fourth divided by x to the third? That is just x, right? So I don't need the 1 there. I just need the x. Now I'm going to take the second term and do the same thing. So 24x to the third divided by my common factor, which is 4x to the third. So 24 divided by 4 is a positive 6. And then when your x's match on top and bottom, they just cancel out. Now notice, in my parenthesis, I have 2 numbers, 2 terms. And I had 2 terms to begin with. Every time you factor a common factor out, you should have the same number of terms here as you do inside here. That's because if I took and redistributed here, 4x to the third times x would be 4x to the fourth. And 4x to the third times 6 is 24x to the third. So I factored out my greatest common factor. So let's take a look at number 8. I'm going to go ahead and do a factor tree on this, even though I know that the greatest common factor between 8 and 24 is 8, right? 8 will go into 8, and 8 will also go into 24. But just so we have practice, I drew it up here, that way it's out of the way. So 8, that would be 2 times 4, and 4 is 2 times 2. And then we already did 24 on this one, so I'm not going to rework it up here. So for 8, you've got 2 times 2 times 2, and then you have 2 y's times y times y. For 24, we have 3 2's and a 3. So 2 times 2 times 2 times 3. And then we only have 1 y. So if we're talking about a greatest common factor, we have 1, 2, a second set of 2's, a third set of 2's, and then we only have one pair of y's. So the greatest common factor, 2 times 2 times 2 is 8 with a y. So we are going to factor out 8y. So remember, factoring out just means you're going to take each term and divide it by that. So 8y squared divided by 8y. I take my original and I factor out my common factor. 8 divided by 8 is 1, so I don't need to write that there because I'm going to have a y behind it. Y squared divided by y to the first is just y. Then you have a negative 24y divided by my common factor, 8y. Negative 24 divided by 8 is negative 3, and then your y's cancel. And I always like to look back and go, okay, if I multiplied this through, 8y times y would be 8y squared, and 8y times negative 3 would be negative 24y. All right, so I'm going to do my greatest common factors here, and we have lots of space now. So 12, which we did 12. Oh, no, we didn't. So 2 times 6, and then 6 is 2 times 3. And then 3 is already a prime number, so there's no splitting on that. So if I write these down, I have 2 times 2 times 3, and then that 12 has 3 x's. X times x times x. And then 3 is already prime, so 3 and then 2 x's. So for the numbers here, I only have a 3 in common, and then I have one set of x's and another set of x's, which gives me a greatest common factor of 3x to the second. So that's what I'm going to be factoring out. All right, so I've got 12x to the third, and I'm going to divide that by my common factor of 3x squared. 12 divided by 3 is 4, and x cubed divided by x squared is x. Just a reminder, you just subtract those exponents, right? All right, then I do the same thing with 3x squared. So I have 3x squared divided by 3x squared. Now here's where a lot of people mess up. If I take 3 and I divide that by 3, I get 1, right? And then x squared divided by x squared, that's also 1, but we just end up canceling. You get 1, right? Anything divided by itself is 1. What a lot of people will do is they do this. But the problem with that is if I start multiplying back, am I going to get what I had originally? No. So that's why I pointed out a while ago, you need to make sure that if you had 2 terms in the beginning, you still have 2 terms inside here. So I still need that plus 1 back behind there. All right, so we've got 20. I'm going to go ahead and factor that out. By the way, if we're just looking at this, though, we should realize that that's going to be 10x to the second. All right, so I've got 2 times 10 And then 10 is 2 times 5. And then I've got my 30 is 2 times 15. And 15 is 3 times 5. So I always write them in order. Like I don't do like 2, 5, 2. I always do like 2, 2, 5, and then 20 has 3 x's. And then 30, I'm going to go in order 2, 3, 5, and 2 x's. So if I look at what I have in common, I have a 2, a 5, and 2 x's. That gives me 10 x to the second. So that's my greatest common factor. I'm going to factor that out. So take your 20 x to the third, and you're going to divide that by your 10x squared. 20 divided by 10 is 2, and x to the third divided by x squared is x. Then we're going to do the same thing with our 30x squared. Take the 30x squared and divide that by 10x squared. 30 divided by 10 is 3, and then my x's are the same on top and bottom. So now let's put that all together. All right? So first things first, you want to make sure that all of your terms are on the left-hand side. All of them. All right? You want to have 0 over here. And then you're going to look at what you have here, and you're going to factor out the greatest common factor. Now, I'm not going to continue doing the factor trees. Um, I'm just going to decide what the common factor is and go from there. So, the biggest number I can divide from 2 and 8 is going to be 2. And then I have an x squared and an x to the first, so their common factor would be x. So I'm going to divide the 2x squared by the 2x. I'll just do it out to the side. So 2x squared divided by 2x. 2 divided by 2 is just 1. And then x squared divided by x is x. So I have a 1x. And then I've got my 8x divided by 2x. 8 divided by 2 is 4, and then my x's cancel, so I have plus 4 equals 0. Alright, so now this is exactly what we had towards the beginning of the lesson, right? We have one factor times another factor equal to 0, so we're going to set both of those factors equal to 0. And we're going to solve for x. So I divide by 2. 0 divided by 2 is 0. And I will subtract 4. So x equals negative 4. So these are the two numbers that if I plugged them into this equation, I would get 0 as an answer. So on number 12, if you'll notice, you don't have a 0 over here. So I'm going to move this positive 15 over to the other side. Now, I cannot combine 6n squared with negative 15n. They are not like terms. So I'm really just going to take this 6n squared minus 15n. I'm just kind of butting them up next to each other. Equals, and then 15n minus 15n just gives me 0. So now I notice, okay, I have a 6 and a 15. So the greatest common factor there would be 3, and then n squared and into the first, so I'll factor out an n. Now I'm just going to divide that 3n out of both of these terms. So I have 6n squared divided by 3n. 6 divided by 3 is 2, and n squared divided by n to the first is n. And then we do the same thing with our negative 15n. Make sure you take that sign with it. So negative 15n divided by 3n. Negative 15 divided by 3 is negative 5, and then my n's cancel. And then I have my equals 0. So now I have 3n is my first factor, and 2n minus 5 is my second. So I will set both of those equal to 0. And I'll solve for n. So I'm going to divide by 3. 0 divided by 3 is 0. And then to solve for n here, first I will have to add the 5. That gives me 2n equals 0 plus 5 is 5. And then I'll divide by 2. So n equals 5 over 2. So 13, I notice that I already have 0 over here. Everything is over here. So immediately I'm going to factor out my common factor. Now this has a 1 and a 5. So those numbers have nothing in common. But I can take out, if I have a squared and a to the first, I can factor out an a. So I'm going to take that a squared and divide it by a. A squared divided by a to the first is a. And same with 5a. So 5a divided by a is 5. So now I have a factor of a and a factor of a plus 5. So a equals 0. A plus 5 equals 0. Now this one, a is already solved for, right? So that's one of my answers. And then over here I'll subtract 5. So a is negative 5. Number 14, I notice that I do not have a 0 over here, so I'm going to subtract the 2x. Now it does work out sometimes where you subtract and you can combine those, but you want to make sure that they're like terms. Ours are not, so we'll just put them next to each other. Alright, so I have a 4 and a 2, so the biggest number that divides into both of those evenly is 2. And then I have x squared and x to the first, so I can take out an x. And then I'm going to go through and divide those. So 4x squared divided by 2x. 4 divided by 2 is 2. And x squared divided by x to the first is x. Then we have a negative 2x divided by 2x. Remember, anything divided by itself is 1, and we have a negative there, so negative 1. So again, two factors. I'm going to set those equal to 0. Over here, I just have to divide by 2. So x is 0. And then here I'll have to add my 1 first. So I get 2x equals 1, and then divide by 2. So x equals 1 half. Number 15. I notice everything is already all on one side. I've got my 0 over here. So my greatest common factor between 4 and 12 is 4. And between x squared and x to the first is x. So I'm going to take my 4x squared and divide that by 4x. 4 divided by 4 is 1, and x squared divided by x is x. And then I'll do the same with my 12x. 12x divided by 4x. 12 divided by 4 is 3, and then my x's cancel, so I just have a plus 3. So now I have two factors, the 4x and the x plus 3. So I'm going to take 4x and set that equal to 0, and the x plus 3 equal to 0. Divide by 4, x is 0. Subtract 3, x is negative 3. Now on number 16, everything's not on one side, so I'm going to go ahead and subtract the 8a. Actually, I'm going to do something a little different. I kind of want my squared term to be positive, so I'm going to add the 10 just to be different. So that's going to leave me with 0 over here. And then I always put these in order, so I'm going to put the 10a squared first, and then the positive 8a. And then it doesn't matter which side this is on, right? You can think of this as being equal 0. My greatest common factor between 10 and 8 is 2. And between a squared and a to the first is a. 10a squared divided by 2a. 10 divided by 2 is 5. And a squared divided by a is a. And 8a divided by 2a. 8 divided by 2 is 4. And then my a's are the same, so they cancel. And see how I just moved my equals 0 to the other side? Doesn't matter which side it's on. So I've got 2a equals 0, and 5a plus 4 equals 0. Divide by 2. So I get a equals 0. And then over here I'll subtract 4. So 5a equals negative 4. And then divide by 5. So a is negative 4/5. You can model the arch of a fireplace using this equation, where x and y are measured in inches, and the x-axis represents the floor. Find the width of the arch at floor level. Okay, so your x-axis, this is the floor, right? This is the floor. Okay, and I've got this lovely fireplace, and they want to know the width of the arch. In other words, from here to here at the floor, right? Well, if you look at your equation, it says that the floor is the x-axis, right? Well, when we do an equation and we factor it and we solve it, how high up are you from the floor if you're on the floor? So if I'm on the floor, how far am I away from the floor? Nothing. I'm sitting on the floor, right? So my y value, the distance above the floor, would be 0, correct? Which means that these factors with the x's represent your distance from here. I want to say that one more time. These factors right here, when I solve for them, represent my distance from the origin. So I'm not going to set negative 1/9 equal to 0 because even though that is a factor, it's not a factor that involves a variable, right? So we're going to kind of ignore that. So we're going to take the x plus 18 and set that equal to 0, and the x minus 18 and set that equal to 0. So I subtract the 18, so I get x equals negative 18, and then I also get x equals positive 18. And what did I tell you these two numbers represent? Your distance from the origin, from the center. So in other words, from here to here is a distance of 18, right? That's on the right side. This point is a distance of 18 to the left side. So all we do is take 18 and add that to 18, which gives us 36, and it says it's in inches. So an important point to take from this is these factors actually represent x-intercepts. Every single time it represents where your graph crosses the x-axis. Every single time you set these equal to 0, that's what these numbers are. So they're your distance from the origin, which is a good thing to remember in later lessons.